horizontal asymptote, they should just call it end behavior. Okay, so like horizontal asymptotes are always end behavior. So like going to the left, going to the right as x gets really big, or teensy small, super negative. Okay, so this is the part that makes it horizontal. So that's how I think about it. End behavior. How does x behave when it goes on forever? How does x behave when it goes on in the other direction forever? Okay, these little horizontal asymptote rules are kind of like your guide for life. Is you're going to take the highest power on your x's and compare them. So we'll do examples because that makes like more sense when we get to it. But these are all the different types of horizontal asymptotes, aka like, look, they cross. That's why I hate the word. Why do they call it an asymptote if they're crossing them? So horizontal asymptotes, you can cross as many times as you want. It's like how it behaves as you go to infinity. So all of these are examples as x going to infinity, but like this one, see, it's like a little cross there. That's fine. That's still a horizontal asymptote, even if they cross. Same here, obviously, same here. Okay. So just kind of keep that in mind. Like, that's how you figure these out. Now, vertical asymptotes, okay, these ones take a decent amount of brain power when you're doing them without a calculator. Okay, so for a vertical asymptote, so on the AP, they'll say like, which one qualifies you as a vertical asymptote? Any of these do. Left, right, equaling some kind of an infinity. Okay, so if you have to the right and it equals infinity, that's a vertical asymptote. Vertical asymptotes cannot be crossed. Horizontal can. Why do they call it that? Doesn't that bother you? Maybe not as much, but it bothers me for sure. Okay, so what happens here is from the left, so from the negative, right? So this still means the same as like the old ones, you know? So that one's coming from the left. This one's coming from the right. Right. This one's coming from the left. Right. And then this one's coming from the right. Okay. So anytime that happens and you get some kind of infinity, that is code for asymptote. Asymptote. Positive or negative. Always going to be a vertical. What was that doing there? I don't know. Okay. Vertical. Okay, so whenever you see infinity as a limit is equal to, then you get asked about. There is an extra credit on the quiz if you got infinity, because we didn't go over that technically. There were a couple people who got it, but there was one where the limit equaled infinity, so you got an extra 2 points on that one. Yeah, if you got that one. Okay, so you might have got 2 points out of it. Great. All right, so this is vertical asymptotes. I think are harder, in my opinion, because they're hard to tell when you're going to get an infinity, if that makes sense. So like you have to use your old knowledge to be like, oh, there's an asymptote there. Like you have to be like old school math, okay? So algebra 2 pre-calc, and be like, if you look at this function, you have to be like, oh, there's an asymptote on that. Right? So like when you're looking at this, you see how you have the denominator is x minus 3, and look what you're doing with your limit, right? You're going to 3. So you have to look at that function and be like, oh, there's an asymptote there. And that's like from knowing things about all of it. Okay. So with no calculator, this is where it gets hard. Okay. Like you're trying to like brainstorm how to do this. So I'll show you with the table if you had a calculator, but also how you do it in your head. Okay. So like with the right side, the 3, okay. So because you're going from the right side, and 3 is kind of like the, that thing, that means an asymptote. Okay. So we're going to do a vertical asymptote. We know that for sure because we know things about like functions and graphs and things like that, okay? So the way you do this in your brain is you have to say that's going to be a vertical asymptote, which means this limit is either going to equal positive infinity or negative. So you have to be like, okay, vertical asymptote, this is how your brain goes. Vertical asymptote, that means the limit as this is going, or the limit is gonna, here I write in words, limit will equal either infinity or negative infinity. That's your only options. Okay, so, but it's like you can't even do anything until you recognize it. So, okay, asymptote for sure at 3. Now I just have to figure out if it's going to be a positive or a negative. So what you do is in your brain, you don't actually have to figure out the values, but you pick numbers cycle close to 3, but on the right side. So like on the right side, so if I did this on like a calculator, just as like a, if we actually had our calculators here, I already plugged these in. I would type in like 3.1, 3.001, 3.0001, and I would get 62, 6,002, 60,002. And like if I even got closer and closer, I would get bigger and bigger numbers. Now, plugging in 3.0001, oh yeah, let me just, I can just come up with that answer. Like, of course not, right? So like what you do, the way you do this in your brain is pick like a number just a little bit past 3 and decide whether you're going to get a positive number or not. Because if it's positive, so like if I put 3.1, that's going to be positive and this is going to be positive. So this limit is going to go to infinity. So I have to narrow it down that this limit will equal this one or that one. I have to pick which one. So once I know it's going to be one of those, all I do in my head is I try to think like, okay, the limit, if I plugged in a number a little bit bigger than 3, like just a tad, okay, that means I'm going to get a positive number, which means this limit is going to equal infinity. Okay, because I only have 2 choices, positive or negative. And then now I do the same thing with the left. So pay attention or think about like, okay, if I plugged in 2.9, 2.99, don't actually get the number because that's cycle, right? Just think about, is this going to be positive or negative? Is this going to be positive or negative? And like decide whether that whole thing is a positive or negative number. Okay. Does that like make sense kind of? I don't know. So like, so if I did 3 on the left of 2x over x minus 3, if I plugged in, like think x equals 2.9, or 2.99, that's going to give me a negative in the denominator and a positive in the numerator. So that means that this limit is going to equal negative infinity. Okay, because I'm between only those 2 answers. Okay. And if you don't believe me, you could also put in your table or the graph of that. If you don't believe me, if you were to type it in, it looks like this. So if you're curious, that's what the graph looks like. But you can see it graphically too. But what they're going to do is they're not going to give you the graph. They're just going to be like, figure it out. Have fun, So it's harder that way, okay? All right, so next one. Is there any questions on that? Because that takes a lot of brain power. Okay? Yeah.
Wait, so you only do that if it's like what it's approaching is the same as what it's in.
Yes, exactly. So if they did 2, I would just plug 2 in.
Okay.
Or actually plug in 3 and you get sad because it's indeterminate. So like anytime you get 0 over 0, it's like you got to do something. And this is the something, if that makes sense. Good question. Yeah.
Would you always have to show like both, like showing from the left side or the right side?
Only if they ask, or if they want like the plane limit, if that makes sense. Like the left, not the left right one, but like the normal one, like x approaches 3. Okay. It just depends what they ask. Okay. So, all right. So now here, this one, they give you a graph and you have to describe it using limits. Okay, so this is like backwards brain in a way. So maybe we'll do vertical because we just got off a vertical brain here. So if we're going to do vertical asymptotes, Okay. That one, obviously we're going to do a limit. Okay. And vertical asymptote is you go to the value and you hit a wall. And you're either going to shoot to infinity or in a negative infinity, right? So your answers are always infinities or negative infinities. Because as you're like going, following the graph left to right, this graph shoots down. It hits a wall at 3, right? So it hits the wall at 3. So that's how I'd write it, as x approaches 3, but not just only when I'm moving left to right. So as I'm coming from the left side, I'm shooting down. So from the left side, I'm shooting down. You could write the function, or I'm just going to cheat and call it k of x. And because it's shooting down, right, that's going to be negative infinity. Okay, so coming from the left, we're hitting our wall. So our x hits a wall and shoots down. Okay, then for the other side, we've got this one. So you're still going to 3, but then on the right side of k of x, but that's shooting up. So that'd be positive infinity. How are your infinities? You got to get used to drawing them, you know? No? Okay. Anyway, horizontal. This horrible name, horizontal asymptote. I hate this name because it's end behavior. Okay, that's what that means. Okay, so end behavior means, that's how I get them mixed up, because it's like, where's the infinity go? They kind of look the same, you know? So like x approaches either positive infinity, so x going on forever, x going on that way, like end behavior. Think end behavior. So that's going to be the limit as x approaches, maybe I'll do negative infinity to start, of k of x approaches. So like for this one, all my y's, like how you think about it, approach like a certain number. Okay, so as you keep going, all my y's get closer and closer to 2. Okay. And then this one, x approaches positive infinity. So as you go that way, has the same end behavior is 2. Okay. So, is there any questions with that? Do you get why the infinities are where they are? Because that's usually what messes people up. They like put these, like get them mixed up. Okay. All right. Okay. So this guy. So we're going to do vertical and horizontal, or horizontal asymptotes and removable discontinuities. If you want removables, just like holes. Actually, I'll do blue for that one. No, I'll do red. This is like your holes. They don't call them holes anymore. It's like too like janky of a name, apparently. Okay, so what you're going to do is you look at your function and then you factor it as much as possible. Okay, so like for that one, you could factor it. So how about just rewrite that quick? Factor it and get your answer. Get back in factoring brain, hey? Okay, and check with your people that everyone's still alive. You got it. Check that you're alive. Okay, so hopefully we're factored fine. Okay, the removables are what you can divide out. Okay, so the removable is when x minus 2 equals 0, aka when x equals 2. Okay, this is your removable. Oops, let's spell correctly. Removable. Okay, so that's at x equals 2. Okay, now it should be easy to tell where your verticals are. Okay, so your vertical asymptote. So vertical asymptote, okay, is what is left on the denominator. Okay, so your vertical asymptote, remember, don't just write -2. It's a vertical line. So you always want to be like x equals -2. Like write it as like x equals. If there's more than one, do not put a comma. Write it as like separate lines. Okay. And now horizontal asymptote. Okay, so this is the new thing. We haven't done one of these yet. Horizontal, you look at the OG. So like the OG equation, and you do janky work. Ready? This is janky. Okay. So this is our janky work. You will eventually not need this work at all. Okay. So what you do is you go back to your OG equation. Okay. Or actually, you should go back to your simplified one. And what you do, okay, so remember it was you take the limit, like this is essentially what you're doing. You're taking the limit as x goes to infinity of x plus 4 over x plus 2, okay? And then you're going to do it with negative. So this is, again, janky work. You shouldn't even have to show work for this once you get the vibes, okay, for it. But what you're going to do is you take the two powers of x, okay, the highest power, so they're both x over x, and you're going to take x over x and reduce it. It's like you're doing this part. It's like you ignore everything else except for the highest powers, okay? So then what you get is you get the limit as x approaches infinity of 1 because they reduce. So then your answer is 1. Hence, your horizontal is at y equals 1. Okay. So, again, janky work. Okay. And you do the same thing with x going to negative infinity. So, obviously, this just equals 1 as well. So, we already got that one covered. So, on both sides, they go left and right the same amount. So again, it's the janky work. It's like not official, but like what you do is you just take these guys, simplify it, and then like plug in infinity basically, or see if it simplifies to a number. So if they have, like say this was a 2 up here, the limit would equal 2. Or if this was a 3 and this was a 2, it would equal 3/2. You just look at the coefficients. The reason is because they divide out in the limit, okay? So, like, let's try another one. This guy, yeah, that's fine. You can, is that even, oh, this, I didn't want to do vertical on this one. We'll just do horizontal on this one, sorry. Let's just do horizontal on that one. Because I don't even think that's factorable. I don't think it is. Okay. So, for horizontal, this is what I'm saying, like the janky stuff, okay? So this is janky. That's a word. I don't know. Maybe, is it? Okay. What you do is you take the limit as x goes to infinity and you just take the highest powers. Okay? So you pretend it's x to the 4th over 3x to the 4th. And then what happens, what happens is if you simplify it, you get 1/3, which means your limit equals 1/3. Okay, so that's one horizontal asymptote, is because they divide out that x over 4, x to the 4th over x to the 4th. And then same thing if you did from the left, but that's not really going to deal with anything because that one's going to be pretty much the same thing because you end up with 1/3 anyway. So that would be the same. Okay. Yeah.
Do we have to show the word for that?
No, this like work, you don't need to show it all. Yeah. It's just more to like why it works. Yeah. So you just look at the highest ones. Okay. Okay. So like these guys, okay, to evaluate the following limits, they'll try to be mean too. Okay. So like, do you see how the denominator, it's like not in order? Do you know what I mean? Like it's got x squared, whatever. Okay. So again, for end behavior, it's this janky work thing again. So janky. Okay. I maybe should just stop saying that. It's kind of bothering me anyway. All right, so we're going to go to infinity, okay, because it says go to infinity, okay? And when x goes to infinity for n behavior, you take the highest powers. Pay attention to when they're negative, okay? So I'm going to take those and pretend this is what my limit is. The reason, and if you take Calc 2, we actually study this a lot, but like as you go to infinity, what's infinity plus a teensy little one added? Do you think it's going to make a big difference if you add a teensy little one? What if you add 2? Is that going to make a huge difference to your infinity size? No. So for these, again, we study this a lot more in Calc 2, but like it's because for horizontals, you only have to look at the highest power because that's what's going to change the most, your values. Okay, so you're going to put that over each other and you're going to simplify it. So for this one, the limit as x approaches infinity, you get negative x, right? X cubed over negative x squared. You get negative x. Now if you plug in infinity, you would get plugging in infinity is kind of goofy, would be a negative infinity. So this limit equals negative infinity. What that means is it doesn't have an asymptote, right? It doesn't approach anything. It doesn't have end behavior. It just kind of shoots down for the graph. Kind of like a parabola. It doesn't have end behavior. It just keeps shooting up or shooting down, depending if it's upside down. Does that make sense? Okay. This one, and then we're going to have you try those calc questions, those AP questions. So this one, again, we're doing limit as x approaches infinity. And again, just focus on these guys, okay, because those are the ones that really matter. Even a squared term doesn't change the size of your infinities that much, okay? So what you're going to do is you're going to do 7x to the 5th over 6x to the 9th and clean it up. So you're going to do limit x approaches infinity. And then as you simplify that, what is that? 7 over 6x to the 4th. Okay. Now for this one, if you plug in a psycho huge number, okay. So if I plugged in, here, maybe I'll put this on here. If you can't think about this yourself, no, I don't want that. Where'd my calculator go? Okay, so anyway, it's not coming up. If I do 7 divided by 1,000,000,000, okay, it gets really, really tiny. So this limit equals 0. On multiple choice in the limit lab tomorrow, you shouldn't have to show any work. You should be able to be like, oh, that's 0. It's bigger on the bottom. Do you see that? So when it's bigger on the bottom, it's going to equal 0. Because think of if you plug in a huge number into the denominator, it's going to be significantly larger than the numerator. Same thing with these. Okay, your numerator is going to be significantly larger than your denominator. Okay, so how about with your people? Ready to go. No calc. No calc. No calc. Oh, geez, that's like a messed up one. Yeah, it's kind of weird how that worked out, but yeah.